right, so next example, we are still using properties of parallelograms, and we are also using distance, midpoint, and slope to classify these parallelograms and quadrilaterals. So the next example I have for you is a trapezoid. The trapezoid is at has points T, R, A, and P. The question is this trapezoid isosceles? So a couple things. In order for it to be isosceles, remember, these sides have to be congruent. So this side has to be congruent to this. So in other words, segment TR must be congruent to segment PA. So what do we know, and what can we use to help us determine if those are congruent? We use the distance formula. So recall the distance formula is D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, the thing that's going to make this a little bit more difficult, once again, is not having integers and using variables instead. So let's go ahead and get started. We have TR first, segment TR. The point for T is negative A and 0, and the point for R is negative B and C. So one thing that you'll need to know how to do is to multiply polynomials and to multiply these out. So let's go ahead and put in our values. X1 is going to be negative B minus negative A is the same as plus A squared plus, I'm going to go to my y coordinates. I have C minus 0 squared. Now, right away, most of you are going to think that negative B plus A squared is simply negative B squared plus A squared. That's wrong. Don't do that. That's wrong. We need to actually multiply or use the FOIL method. So, we have negative B plus A squared. Remember, I'm multiplying it by itself. So yeah, I told you wouldn't like this, but I mean, it is what it is. Negative B squared gives me, or negative B times negative B is B squared. Negative B times A is just negative AB. Then I'm going to come here and I'll multiply A times negative B. I have another minus AB. And then last, A times A is plus A squared. So now this is the expression that matches this. So I'm going to kind of substitute that in. I have TR. Segment TR is equal to the square root. Now remember, all I did was FOIL negative B plus A. I just squared it. So let me backtrack a second. C minus 0 is simply C. C squared is just C squared. So now I'm going to take this, and I'm going to take this, and I'm going to rewrite it here. So I end up with A squared. I have minus AB, which is the same as minus 2AB, plus B squared, plus C squared. I can't simplify this anymore, so this is the distance of segment TI. Now, I'm not done because I still need to find the distance of PA. Once I find the distance of PA, I can compare the two. Once I compare the two, then I can determine whether or not this trapezoid is isosceles. So this is TR. We are going to move over to the other side and let's do PA. So we have PA, and with PA, you should kind of do this one along with me. I have x1 minus x2 squared plus y1 minus y2 squared. So my points for P are A and 0. My points for A are B and C. So I'm going to start with P. I'm doing A minus B squared plus 0 minus C squared. So once again, you see I have this A minus B squared. So I'm going to FOIL it out for you. A minus B times A minus B. And notice I get the same thing as I had over here. So I'm going to go ahead and simplify even more. Once again, 0 minus c is just negative c squared. And you know negative c squared is c squared. So now I'm going to take my expression. So I have this and this expression here, and I'm going to simplify it even more. Combine like terms if necessary. I have a squared. I'm going to combine these, minus 2ab plus b squared plus c squared. And what you notice is this expression is the exact same as this expression. Which means, yes, this is an isosceles trapezoid. And my explanation would be because segment TR is congruent to segment PA. Now you try, or come back with questions.